In foreign cities, we often see trees planted near highways and pavement to combat noise pollution. But such scenery is rare in our city of Hong Kong. That is why in this video we would like to propose the idea of looking into noise distribution in Hong Kong and the effects of vegetation.
According to the Hong Kong Legislative Council, in 2019 alone, 5,099 noise pollution complaints have been received, taking up 22% of all pollution complaints. Amongst them, industrial and commercial were the largest noise generators, accounting for 53% of the complaints. They said noises are mostly emitted from retail stores and restaurants near residential areas. A recent study conducted by Hong Kong New revealed that 76.3% of households are exposed to excessive traffic noise based on WHO standard of 55 decibels. Not only children are prone to noises-induced hearing defects, continuous exposure to noises and the follow disturbance of sleep can contribute to stress accumulation, affecting one's mental health. On physical health, one study linked long-term exposure to noise above 65 decibels to the raises of the risk of having cardiovascular disease due to the buildup of stress hormones and the increase of blood pressure.
To improve noise conditions, trees can act as noise barriers and reduce noise pollution through a phenomenon called sound attenuation. Sound attenuation happens when sound waves dissipate over long distances until there is no energy left to vibrate the air. Trees attenuate noise by absorption, deflection, refraction, and masking. There are different properties of vegetation which affect their capabilities to absorb, deflect, and refract noise. For instance, studies have suggested that the structure of a tree, including height, branching structure, leaf shape, and density, determines how effective it is at absorbing sound. Hence, through this investigation, we hope to create a model to establish the connections between different factors and the vegetation's capability to reduce noise levels.
With regards to the methodology, there are 4 steps in total, including data collection, statistical modeling, hypothesis testing, and index creation. For noise data collection, we'll utilize the mobile app named dBmeter. It allows us to measure the sound level in the surroundings. We will visit different districts in Hong Kong and measure the corresponding noise levels. Photos will be taken for recording the surrounding environment during all the measurements. Passive remote sensing will be applied for vegetation data collection. Sun emits electromagnetic radiations, and vegetation will reflect light with unique wavelength as compared to other objects on the Earth. When satellite orbits around the Earth, the reflected light is detected and images are captured. We can filter the wavelength of the reflected light to visualize the vegetations in Hong Kong. For example, the band combination of short wavelength infrared 2, 1, and red can show the density of vegetation on the image from the satellite Landsat 8. The greener of the area, the denser the vegetation is. Besides the visualization of the vegetation density, we can directly quantify the vegetation in the area of interest. To do so, we can first obtain a raw Landsat 8 image from the database called Earth Explorer. After that, we can import the image into computer software termed ArcGIS. It is a powerful tool that allows us to input the equation of the vegetation index and ask ArcGIS to compute all the values in a specific area. Hence, we can easily obtain a spreadsheet filled with the vegetation indexes for further analysis.
With the data collected, we would then clean the data and quantify non-numerical data such that we could analyze them. Then, with the clean data, we would find the level of connection among the data collected. For instance, finding the connection between the noise level distribution and noise pollution complaints to spot the places in Hong Kong with the most irritating noise pollution. Through the use of regression models, we could also establish the connection between different properties of vegetation and their performance in attenuating noise. To ensure a high accuracy, we could conduct tests for model selection, like R-square tests, standard error tests, correlation tests, and logical tests, such that we could filter out factors which have lower correlation. At last, with the most accurate model selected, we could use it as a reference to create the efficient vegetation index, such that it could be easily used by urban planners and engineers.
Our expected outcomes include obtaining a better insight into the noise problem in Hong Kong, making better advice on appropriate vegetation amounts for improvement in urban planning, and to better apply AI and machine learning by combining them with the vegetation index created to make automatic estimation of the vegetation amount needed.